So hello, my name is Romain, and I'm a data scientist at BlaBlaCar, and I work on search recommendation. Today I'm going to present a bit what we've done. So the website looks like this. So when you search on BlaBlaCar, you need to input a from, a to, a date. And then what's going to happen is that we're going to show you a list of results that shows something like this. And because BlaBlaCar actually have been very successful in the last few years, you're going to realize that there's a lot of trips. For instance, in a search like this one, Paris-Toulouse on a Friday, there's already 33 trips. So the question that we came to ask ourselves, and that's a great question because it comes because the website is growing, is how can we help our member to find the best ride easily? Mainly it's the product people who thought about this idea, and the simple answer they had is to add a trip on top of the classic trip that we display that we call the search result. And this trip is called the top of search because it's on top of the search, and it's going to be recommended by us as the best trip you can find for your given search. So you can see it on the search because it's labeled as a green slope on the left, and it's called best trip. All right, so once we're there, the product showed us this. We were interested as data scientists and AI people to know which trip we should put in there. And because we're in a business environment, the idea is not to put ML right there right away, but it's to think also about basic rules that we should put in there. If you think about basic rules, basically you're going to go with one-dimensional rule first. So maybe everyone prefers the cheapest. So the easiest way to go is just to say, okay, on that search, what I'm going to recommend is the cheapest. But it could be also the closest. So the idea is just you choose one dimension and you push for this one. Quickly, you're going to realize that this is a bit too limited, and of course, this is not always the cheapest that you want. So you're going to go maybe with more complex rule, like hierarchical rules. And you're going to say, okay, actually, I want the closest from the departure, the closest from the arrival, but if there is a draw, then I'll choose the cheapest. Same problem here. You might think that it's too limited, and you want to go with more complex rule, like the scoring rule. And you know from past analysis, for instance, that actually the price is 10 times more important than the distance, or than the time, etc. So the idea here is that no matter what rule you can design, it's going to become more complex, and you're going to run into several limitations. Mainly, we found two. So if you use a simple rule like this, the complexity is going to be limited because our brain can only handle a few parameters. So it's going to be able to handle 2, 3, 4 variables, but then once you have to judge how to decide for the best trip among 10, 20, 100 parameters, it's going to be very complex to arbitrate. On the other hand, if you choose a rule, it's going to look towards people that it's a bit arbitrary. And how do you choose the coefficient, for instance, in a scoring rule? How do you choose the hierarchy in the parameters? So that's quite complex. Second limitation that we have is that BlaBlaCar operates in about 20 countries. So if you design a rule by hand like this, you're going to have to design it 20 times. And if you make a change in the product, the price change, or competitor enters the market, so you have behavior change, then again, you have to redesign this rule. So this is where we thought that machine learning was a good use case for us, and we use machine learning for this stack to predict the best trip. Because the first limitation can be addressed with machine learning. First, you're going to have the nonlinear model that are very famous. We talked about deep learning in previous conversation, gradient boosting, etc. And they're going to be using past data, so it's going to bring a justification on why to choose this algorithm or this specific trip. And the second problem that we had of retraining the model is now super easy because once you've defined your structure in your model, you just need a new data set for the new country or for the new user or for the new behavior, and you can adapt your algorithm. Okay, so now that we decided that we actually wanted to do a machine learning recommendation, the idea was to go and build it. So we're going to go a bit into the magic, which actually isn't magic. This is built for non-ML people, so there's no magic in there. It's one simple equation. And what the equation we're trying to solve is this. We're trying to predict how to know, given a search and a trip, what is the likelihood that you're going to book this trip, that a passenger is going to book this trip. So what does it mean in a more concrete example? It means that given a search, like Paris, Montauban, it's a city in the south, for the one who don't know, on February 2nd, I have to choose in this list the trip I'm supposed to recommend. And for each trip and this search of the parameter, I'm going to predict the probability that the person is going to book this trip. So let's say 5% for the first one, and 7% maybe for the second one, and so on and so forth. And so in the end, in the search result list that I have, I'm going to be able to think that according to us right now, to our algorithm, there's 15% chance this is the highest trip you're going to book, so we're going to recommend this one and put this one on top of the list. So it's going to avoid you the hassle to go through the entire list. And for us, this is our best guess. This is the trip you should book. So usually when you build machine learning algorithms, there's a few steps that everyone follows, so I'm going to go through them and explain how we manage to build our algorithms. First, collect data. To collect data, you need the search parameters, but also you need all the search results, so everything people have ever seen on your website. For BlaBlaCar, it's a huge amount of data operating in 22 countries. You also need to record where people clicked, where people booked, and etc. Once you have this, you can go to your second step. Second step is about cleaning the data. So cleaning the data is actually a step that is very often underestimated, because not only are you going to remove tracking errors, you're going to remove inconsistencies, for instance, by removing whatever data point that you seem is not fit, but you're also going to answer other questions that are actually starting to be part of your model, because you're going to answer questions such as, what did I do if there is no interaction in this search? Can I use this search to learn something from it or no? What do I do if there was a cancellation? Should I count this booking as a really as a booking, or actually was it maybe a mistake or something else? So this step of cleaning data is actually super crucial, because this is the first step of your model. This is where you decide what your data is going to be. Third step, which is the most famous of machine learning, is training the model. Training the model, as we said, it's like finding the F that is in this equation, so finding the F that's going to mix the search and the trip to output the probability that someone is going to book. Most people in this room should know this kind of problem. It's a logistic problem, so binary outcome. We build a set of features using the search and the trip information. So a few examples here, the distance between the search and the trip arrival, the distance between the search and the from arrival, the time, for instance, of the trip. We're also going to use feature of the trip. For instance, we have a mode on BlaBlaCar where you can accept automatically ride. So we're going to use a bunch of features like this to finally build our model. The choice we've made at BlaBlaCar is to use gradient boosted tree, because they work really well on business data. Anyone that's been on Kaggle a bit seen that they won a lot of competition. And so this is the choice we've made. So also because we're business-centric, there's no talk about deep learning, all of this, because first is to go to a solution that works and that is super robust, not something that is state-of-the-art. So now we've done the first three steps, and most of you who have worked with machine learning before should know that the last step is validate the model. So to validate the model, I'm going to be super quick over this, but you basically take your train set, you split it in two, and you measure the performance on your test set, and you hope that it's going to be better than random, or better than your basic algorithm, your basic benchmark. So once you've done this, your work as a data scientist, machine learning engineer is pretty much done, because you have a model, it's trained, you know how to predict the result that you want to predict, which is the trip you should recommend. But actually, when you work in a business or on a platform like BlaBlaCar, this is only half of the work. Then the second half starts, which is basically implementing. So now I'm going to spend a few slides on explaining how we implemented this kind of algorithm on BlaBlaCar, what are the choices we made, and what are our learnings. So first, the constraint, it starts there. So to decide on how to implement this, we first look at what were the constraints of the implementation. The first thing is that it has to work in Java and in Python, because data scientists work with Python. As you know, Keras, TensorFlow, scikit-learn, XGBoost, all of that works super well in Python. And our backend, and a lot of backends are actually built in Java because it's faster. It has to be fast, so it has to handle a lot of prediction. Because if you think about this kind of system, at every search we're going to make several predictions for each trip, and we don't want the search to be super slow. We don't want the search to take 10 seconds because we just added one top of search trip. So we want this implementation to be fast. Finally, also, we want this model to be performant in the sense that we don't want linear regression only to be implementable. We want to be able to implement actually what we train, so gradient boosted trees, but maybe also later other packages that could be even more complex. And finally, we want a robust implementation. The search at BlaBlaCar is a super important part of our product because it's the entry point for all the passengers. So if you break down the search, you break down BlaBlaCar. So we want this to be robust. So what we did is that we sat down with a software engineer, and we did a few short lists of the package we thought were good candidates. And finally, we did a benchmark that's actually available on Medium, so you can find it as a fast machine learning prediction, and it was done by Eduardo, one of the software engineers at BlaBlaCar. And we came up with the solution that is here. So we choose to use XGBoost in Python for all the offline analysis data scientists work. And we use another complementary library that's called XGBoost4j that is used in production on the search service, and that allows us to predict whatever we train with XGBoost offline. So now, if you look back at the timeline, we've actually made it to the fifth step, And everything is implemented, everything is running, and we still have one big step to do. And this is the step we think now is the most critical, and we invest a lot of time in doing this step, which is actually testing the model in production. For those of you, this is why I'm going to spend some time at the end now to talk a bit about A/B testing in production. For those of you who've followed a bit and seen that first we validated the model, may be wondering, why do we need to validate, but also to test in production? So the test in production is going to also allow you to define different problems than the validation. So for instance, you're going to find new problems, such as the fact that your data, for some reason, in production, changed a little bit. So there was some problem with rounding, there was some other problem with the data pipe, something slightly changed. And even though your test tech are working and your website is functioning and you're still making prediction, for some reason, they're all a bit off. You're also going to be able to find problems such as, okay, you try to select the best training set, you try to select the best testing set to make sure that your performances were well predicted, but actually, for a reason that you don't understand yet, there was some bias. So this is where A/B testing in production for us is super critical, and we do it with every model that we roll out. To have a quick overview of what is A/B testing, it's just a test where you put 50% of your people usually, or whatever percentage in one group, and whatever percentage in another group. So in the search page, for instance, 50% arriving on the search page will see an old algorithm, and not our new machine learned one, but more something around price. And 50% will see our new algorithm. What we're going to do is we're going to take those two groups and measure different business KPI. And that's why also A/B testing is very interesting, is because it allows us to see the business impact of what we build. So in this case, we show the number of booking, but also the percentage of booking that were done in this recommended section. So the results were pretty compelling, because the percentage of booking on that specific trip recommended increased by 2.5, so plus 100%, 150%, which is a huge win, according to us, because it means that people who booked there, and a lot more people booked there, they didn't have to go through the whole list. They immediately saw a trip that was interesting them and that was fit for the trip. So it means that using machine learning, we were able to improve the user experience. In case you were wondering, we're actually not able to increase the number of booking. So we're not able to actually change whether people want to book or not, but we're still able to help them find a better ride. All right, so that's all for search recommendation. And I'm just going to finish quickly with a machine learning project at BlaBlaCar to give you a quick overview of what we do. So today we talk about product and search recommendation, quick overview. But there's also a lot more that we do and where we use machine learning, because as any company, we now think that it's a lot of thing we can play and help us with. So we use meeting point recommendation, for instance. If you publish a ride on BlaBlaCar, we're going to recommend you the best meeting point. We use it for pricing. We use it for search eligibility, so it's not deciding which trip we should show in the search or not. And even more project, and more to come. There's also community support, which is the whole part of vertical BlaBlaCar that handles the community, so the members of the website. And here we do content moderation, a lot of content moderation. So we have robots that are reading all the messages, the rating, the comment you can write, and make sure that there's no insult, and etc. We also do fraud detection, for instance, to detect people that have bad behavior or people that would make money, because carpooling is not supposed to make money with. Finally, we have another branch where marketing is heavily used as of today, and this is marketing. Marketing is predicting next likely trip or churn prediction, which allows us to actually make sure the marketing is targeted. We're not spamming people, but we're still sending them relevant email when they need to. That's all from me today. Thank you very much for listening.